Hey everyone, welcome back for another deep dive. And today we're going right into the heart of AI. Those large language models, LLMs, you keep hearing about, they're writing poems, composing music. But here's the thing, they're getting huge.
Yeah, massive.
So big that they need tons of computer power.
It's a real resource hog, and that has, well, implications for cost and accessibility, even the environment.
Definitely. And traditional ways to shrink them down haven't really worked out.
Like just simplifying the numbers they work with, right? That hasn't really been the best.
Right. So that's the problem. Amazing.
Yeah.
But needs a supercomputer, basically.
Yeah.
Enter BitNet.
Oh.
B1.58, the star of our deep dive today.
Okay.
It's a whole new architecture. And the researchers are saying it can do pretty much the same stuff with way fewer resources.
Yeah, they're really saying this is a potential game changer.
Yeah, they're calling it the era of one-bit LLMs even.
What's really interesting is that BitNet uses a totally different approach.
Okay.
It uses a simplified system for calculations instead of using super precise numbers.
So instead of a crazy detailed map,
Yeah.
more like navigating with basic directions.
Basically, yeah. And what's fascinating is that even though it seems simple, this change, it really has a huge impact on efficiency.
Really?
Just imagine trying to do all these complex calculations using only whole numbers instead of decimals. It's much faster, and it just needs less memory.
Okay, that's cool in theory, but does it actually work? Did they actually test this BitNet B1.58?
Oh, yeah, they did. And the results are really pretty impressive.
Okay.
They actually compared it to Llama, which is a full precision LLM,
Okay.
even with a model size of 3 billion parameters, which is still huge, by the way. BitNet B1.58 was able to get pretty much the same performance on things like text prediction and accuracy.
So same smarts, but way less demanding.
Exactly.
That sounds like what they call a Pareto improvement.
You got it.
Getting better results without sacrificing.
Yeah, BitNet B1.58 was 2.71 times faster than a Llama and used 3.55 times less memory.
Wow.
And get this, it could potentially use 71.4 times less energy.
Wow, those numbers are mind-blowing. So this isn't just about making AI a little bit better. This is a whole paradigm shift.
Exactly. The whole idea that bigger is better, that's been the prevailing thought.
Yeah.
But BitNet B1.58 is saying, no, you don't necessarily need to just keep making these models bigger to make them better.
So maybe smaller, more efficient models are the future.
Right.
How did they do it? What's the secret sauce?
Well, one of the big things is the quantization function they used.
Okay.
So this is what converts those high precision numbers into those simplified -1, 0, and 1 values.
Okay.
Think of it like compressing a detailed photo into a smaller file size, but without really losing important information.
So they're simplifying the data, but not the accuracy.
Exactly.
But didn't you say that just rounding numbers down didn't work? What's different here?
They didn't just round them randomly.
Okay.
They use this technique called Absminian quantization. It's pretty clever, actually. It scales and rounds the values based on the overall weight matrix.
Okay, that sounds pretty technical. But the takeaway is they found a really neat way to simplify those complex numbers without losing what makes the model smart.
Precisely. But it gets even more interesting because adding 0 to the parameter set, creating that 1.58-bit system, that was a big breakthrough.
Why? What's so special about 0?
It basically acts as a filter.
Okay.
It lets the model choose what information it processes. Think of it like a spotlight that can really focus on details and ignore distractions.
So it's not just on or off anymore. The 0 adds a layer of control.
Yes, exactly. And this filtering has a big impact on both performance and efficiency.
Okay, so BitNet B1.58, smaller, faster, uses less energy. But what about actually using it? What does this mean for the future?
Well, one thing the researchers highlighted is its potential for things like mobile devices.
Oh, wow.
Which have always struggled with AI,
Yeah.
So instead of needing these huge data centers, we could have AI processing right on our phones.
That's a game changer.
Yeah.
Imagine the possibilities, personalized apps, things that work offline, even better privacy.
Absolutely. But it's not just about individual devices. This could change entire industries: healthcare, education, transportation, manufacturing.
We were talking about an AI revolution driven by efficiency and accessibility.
Yeah.
But hold on, we can't get too carried away. What about the downsides? What happens when this technology gets into the wrong hands?
That's a crucial question. And we need to be cautious about things like misuse, algorithmic bias, and the concentration of power.
Right. So it's not enough to just celebrate the advancements we need to think about the challenges too and how to prevent harm.
Exactly. We need strong ethical guidelines and transparency in AI systems, and to make sure that this technology is used for good.
This is where things get really interesting, and we'll explore all of this more in the next part of our deep dive.
Stay tuned, because what we're about to explore could really change the way we interact with technology and maybe even the world around us.
And that's it for part one.
See you in part 2.
Bye.
Bye.
It's crazy how just shifting to like 1-bit parameters can have such a huge impact. Yeah, it's like they found this hidden switch that just unlocks all this new potential. But what else did the researchers find out about BitNet B 1.58?
Well, one cool thing is how this architecture could actually address a big limitation with LLMs.
Okay.
You know how they have a limited context window?
Like a short-term memory limit.
Yeah, exactly. Like trying to read a book and forgetting the previous page.
Yeah, you lose track of the whole story.
Exactly.
So how does BitNet B 1.58 fix that?
Remember how we talked about it using less memory?
Yeah.
Well, that means it can have a much larger context window.
Oh, so it can hold more information, basically.
Yes, exactly. So it can handle longer, more complex pieces of text.
So it can remember more of the story, make connections across more information. That's a big advantage.
Exactly. Imagine what that could do for things like scientific research or legal analysis, even creative writing.
Wow.
Analyzing huge amounts of data, finding hidden patterns, writing better stories.
That's amazing. But even with those improvements, there's still a limit to how much information it can handle, right?
Well, the researchers think that BitNet B 1.58 could be combined with other techniques for even longer sequences.
Oh, really?
They mentioned something called memory compression.
Memory compression, is that like zipping a file to make it smaller?
Kind of. It's about finding better ways to represent information within the model using less memory, but without losing accuracy.
So it's like a double whammy. First, you shrink those parameters down to 1.58 bits, and then you compress the information itself. It's like fitting a whole library in a shoebox.
It's really impressive how creative these researchers are, and this focus on efficiency, it has implications way beyond just making things smaller.
You're talking about LLMs on everyday devices, right?
Exactly. Imagine your phone understanding complex commands, having real conversations, even writing creative content without needing the internet or draining your battery.
It would be like having a genius in your pocket. But wouldn't we need better hardware for that?
That's true. It's not just about software. We need better hardware, too. The researchers think we'll need chips that are specifically made for 1-bit LLMs.
So instead of trying to make these models work on the hardware we have now, they're saying we need to design new hardware that's made for efficiency.
Exactly. And these new chips could make it possible to run these powerful AI models on devices with limited battery and processing power.
It's a cool idea, but what about the companies that are already using traditional LLMs? Will they have to start over?
It will definitely require some adjustments, but the good news is BitNet B 1.58 actually uses parts of existing LLM designs.
So it's not a complete overhaul.
Right. And the benefits are so big: cost savings, energy efficiency, new applications. I think we'll see these 1-bit models being used everywhere once the technology is ready.
It's like when we switch from big desktop computers to laptops and smartphones. Once people see how much better the new technology is, there's no going back.
Exactly. But let's think bigger than just devices. What about the impact on society as a whole?
Yeah. What happens when everyone has access to this powerful AI?
It could really democratize AI, making it available to people who couldn't use it before: individuals, small businesses, even whole communities.
It's like giving everyone a superpower, but with great power comes great responsibility, right? How do we make sure this technology is used ethically?
Those are important questions, and that's what we'll be talking about in the next part of our deep dive. We'll explore the ethical side of this, the potential risks, and what we all need to do to make sure AI is used for good.
So get ready, because we're going to dive into some uncharted territory where technology and ethics and society all come together. It really feels like we're at the beginning of something big.
Definitely, like AI is going to be everywhere, not just in labs.
Right. But as with anything this powerful, there are risks we have to think about.
For sure.
We talked about how efficient these LLMs are and how they could be on our phones and stuff.
Yeah.
But what about the downsides? What if it gets into the wrong hands or makes existing problems worse?
These are really important questions.
Yeah.
We need to be so careful about
Hey everyone, welcome back for another deep dive. And today we're going right into the heart of AI, those large language models, LLMs. You keep hearing about they're writing poems, composing music, but here's the thing, they're getting huge.
Yeah.
Whoa, did someone just break the fourth wall? Let's hear it.
Hey there. Can we explain the overview intuition of this study and the BitNet, the key points of this study?